Next, we'd like to introduce some terminology regarding the sets that these functions are mapping to and from. And that is the domain and the codomain of a function. So say we have a function f that's going from the set A to the set B, and we have names for those specific sets. So set A is called the domain of the function, and this is the set of possible elements that we can start from. And set B is called the codomain of the function. So this is the set that the function can take values to. So if we take a function f, it's going to map an element A from the domain to an element f of A held within the codomain. So the codomain is our set B, the domain is our set A. Let's take a look at a function that we've already seen, which is the square function. And so it can start from any real number, and it's going to take a value from the reals, a value x, and it's going to map it to square of x, which is also represented as x squared, x to the exponent 2. Okay, so we know then that the domain is where we start from, and the codomain is where we move to. So this is our codomain over on the right, and that's all fine. But let's take a look at where this function can actually go. So we've got a starting point. Yeah, we can start from any real. Is it possible that we're not going to make use of all the reals on the other side? Well, let's take a look. So as an example, we can consider, well, where does 5 go to? 5 goes to square of 5, which is 25. 7 is going to go to square of 7, or 49. 8 is going to go to square of 8, or 64. Okay, and we can see that can keep getting bigger, and I'm only looking at integers right now, but I can fill in the gaps in the middle because I can look at the square of 5.001 and get something quite small and fairly close to 25, right? And if it's not small enough, I can go a little bit smaller. But what about the negative numbers? Well, let's try starting from the reals that are negative. I can start from a -5. -5 is the square of 5. Oh, but when I square -5, I get back a positive number. I get back 25. And when I square -7, I get back 49. And so -5 is going to map to 25. But wait a minute, 5 is also going to 25. And for every positive number going to square of x, there's a negative number going to square of x, right? So x maps to x squared, but in this scenario, negative x also maps to x squared, because negative x all squared is equal to x squared. We have this situation where we're never going to get back a negative number. If we square a positive number, we get a positive number. If we square a negative number, we also get a positive number. And so, in fact, what that means is the areas that we can actually reach within that set are only those real numbers that are positive. So for a given function, f, mapping from A to B, the range of the function is the set of all the values B within the codomain, such that there is an A from the domain that will map to it. So what that means is you can somehow reach it. And so in our example of squaring, we can only reach the real numbers that are greater than or equal to 0. I know I can reach 0 because I can square 0 and get back 0. And then I can reach all of the other reals. But what I can't do is reach any of the negative real numbers. And so the range for a square function is to find, it's the set of all the b and b in the codomain such that there is an a in the domain such that f of a is equal to b. That's a mouthful. But what it means is there's a mapping from the domain to the codomain that's going to hit that number. And so I know that I can take an x from the reals and reach an x squared within the codomain of the reals as long as it's greater than or equal to 0. But what I can't do is hit the negative numbers. One interesting example of this comes up when we think of web-safe colors. And this is the term that's been around since the start of web. And it originated from the fact that people had limitations on the amount of RAM, especially when it comes to RAM dedicated to video. And so just as in the description earlier about RGB colors, that red, green, blue, web colors, how we represent colors on website pages, are represented as a combination of red, green, and blue. In this environment, they're instead represented as hexadecimal numbers ranging from 00 to FF. And you'll certainly have a chance to learn about hexadecimal numbers in other courses, but essentially 00 is a representation for 0, and FF is a hex representation of the number 255. So we had 256 colors to choose from, as depicted before, and they were going to represent the amount of red, the amount of green, and the amount of blue. We would present an ordered triple and define the amount of color. Well, that sounds great. For each of those colors, I can choose from 0 to 255, but just as we looked at that compression, essentially web-safe colors are a form of compression. They said, well, you know what? People don't have enough RAM to withstand that much information. That's 256 possible colors for red, green, and blue. Instead, we need to store less information, and so we're going to allow you to choose anything from this possible set, 00, 33, 66, 99, CC, and FF. And so if you have colors within a certain range, we're only going to present these. These are considered the web-safe colors. And that's because this then can be expressed as an 8-bit color. And so if you had 512 kilobytes of RAM 10 years ago, this would be a safe amount of information that you could display, because this results in 6 times 6 times 6, 6 options for each of the red, green, and blue, or 216 possible colors. So we needed to store that information in less than 8 bits, which can be done as long as that number is less than 256 in total. And this is. In today's world, it's not as much of an issue. I have 16 gigabytes of RAM. And so storing that greater amount of information so we get a wider palette of colors is not as risky anymore. The only downside is that older, slower computers might not see it. So depending on who you're putting the information out to, you just weigh that risk.